Good afternoon, students. Myself Sandeep Raj from IT department, Engineering AKGEC Engineering College, Ghaziabad. We are going to learn today. We are going to learn single source shortest path problem, in which we see the algorithm, discussed algorithm. So, what is single source? Means if one graph is given to us and we have to find the single source, means from a single source to a one destination, a single path means shortest path, then this algorithm will work for that. What is single source shortest path problem? It is a greedy method type problem. The greedy method type problem is the category in which we can segregate the algorithms in greedy, dynamic and other type of the backtracking. So many types are there, and then this type of problems are comes under the greedy methods, in which we have single source shortest path problem, which we are going to see today, in which this Casta algorithm is there and Bellman-Ford algorithm is there. What is the difference between these two algorithms? This Casta algorithm used for the positive weights. When positive weights are given for a graph in which we have to find the we have to find the shortest path from a single source to some all destinations or all the possible nodes. And another one is Bellman-Ford algorithm, in which negative weights are also given, for which we have to find out the same thing, means shortest path from a single source to all destination nodes. What is single source or shortest path? Again, in a shortest path problem, what is the what is the definition of this? In a shortest path problem, we are given a weighted or directed graph. Means a directed graph has been given for that, which is weighted, means a graph G is given with vertices V and edges E. The edges and vertices, we have given a graph which contains some vertices, which contains some edges, and which is also a directed graph with some weights, with weight function W, and W is mapped with the edge to some value R. Mapping edges to real valued weights, means every edge mapped with some real valued, means 2, 3, 4, 5, 6 or so on. The weight of the path P means vertices 0 to vertices 1, or vertices 1 to vertices 2, vertices 2 to vertices 3, so on. Means if there is a path from vertices 0 to vertices k, that will be the sum of the weights of its constituent edges. Means weight of the path W of P, weight of the path is the sum of all I is equal to 1 to k, means vertices 0 to vertices k, will be W of Vi minus 1 to Vi, means weight of the path will be the summation of all the edges which comes in that path only. Then we define the shortest path weight. If we found all the path weights and we have to find out the shortest path, it means shortest path between U and V. If there are two vertices U and V, and we have to find out the shortest path, it means we have to find out minimum of WP, which we have measured here. If we have measured WP for a single vertex or single destination, there are 2 or 3 options are available, then we have to take minimum of among that, means U to V. If we have so many values are there, then we can take only minimum value, means if there is a path from u to v, and if we do not have any path between u to v, we will take infinity only, that is written here. Another one, many other problems can be solved by using by the algorithm for the single source shortest path problem, including the following variants: single destination shortest path problem, this is the one of the kind of problem; single pair shortest path problem, and all pair shortest path problem. These are all in between another kind of problems in this category. In some instances of the single source shortest path problem, there may be edges whose weights are negative. So, we are going to learn here Dijkstrata algorithm. First, we will see what Dijkstrata says. Dijkstrata algorithm is work for only positive weights. In this, we do first thing, initialize a single source. If some graph has been given, firstly we have to initialize a single source, means for each vertex v which belongs to vertex of G, means all vertices of graph G, for all vertices, for each vertices we have to define the value, means d of v we have to initialize infinity, and d of s we have to initialize 0. Then what is the d? D is the distance or the value of path. The distance of source node we have to initialize distance of source node at 0, and distance of every vertices other than source node we have to initialize it as infinity. And pi of v means parent of vertices v, means other than source node all vertices v are there, then there will be no any parent for any vertex. Pi is here also written as parent node of each vertices. This whole process is called initialize a single source, means here we have initialized a source S, which distance is initialized as 0, and other all vertices are initialized as infinity, and there is no parent node of any vertices. Second part is relaxation. When we go to some another node from a single source S, say S, we have to take care of the next process is called relaxation. We call relax U, V and W, means U is the starting node, V is the destination node, and W is the weight that consumed for traveling from U to V, in which we check if d of V, means distance for reaching V, is greater than distance for reaching U plus weight of U comma V, means if we are at U and we have next node as V, then there will be a edge between U and V, and which contains some value W, which we call W of U comma V, means the weight of that edge. The weight of that edge will be added to distance for reaching the starting node, means d of U, and that will be less than, or we can say distance of V will be greater than of this whole thing. Then we have to check this thing. In next step, if this will be okay, means if dV greater than du plus W of U comma V, then dV initialized as du plus W u plus v, means if this was initially infinity as we have taken here in initializing the single source, we have taken dv as infinity, and here if we found the whole thing as, for example, du says 6 plus and weight of this thing plus 3 is equal to 9, then we can say infinity is greater than 9, which is true. Then we have to take this minimum value. That's thing here in step 2 is initialized as dv tends to this whole thing which is smaller than original dv which has been initialized step 1. Next one is step number 3, pi of v. Pi of v means parent of vertices v is u, means from which vertex we go to vertex v, means from v u we reach the vertex v. We have seen here weight of u comma v we have taken here in step number 1, means we were at u, now we are at v, means vertex of v is u, means the source node from for v. This is the two steps are there. First one is initialize a single source, second one is relaxation at each node, means from source node we have started and for each node where we reached we have to relax there and compute the value which is minimum for that part reaching there. Next step number 3 is Discastra, means for graph G there will be the some weight which gives the shortest path and there is a single source S. So initialize a single source which is we have seen here, initialize a single source which is this thing, then source S initialized as phi means source node value, and Q initialized as vertices of all G means all vertices of that graph are given into Q, and in set S we have given phi. Then while Q not equal to phi means till then Q will not equal to phi, we do U extract minimum value of Q. When we find the minimum value of Q, we will take it as U, and in next step we compute or we include this U node in S set. There is two sets S, there are two sets S and Q, and when we find the U node or U value which is the extract minimum value from here relaxation, when we found the minimum value like this, then we add that particular node in S set, means set of covered vertices, means which vertex has been covered we will include that in set S. So then next step, for each vertex V belongs to adjacent of U, means if we have covered U then we see all the V vertices which are adjacent to U, means covered vertices, all or already covered vertices. Then we call relax of U means covered vertices, V means to be covered vertices from U, and weights for covering from distance covering from U to V means minimum distance covering from U to V by calling this relaxation node, relaxation part. Now we can see this thing by this example. We have this question, we are having S, T, X, Y and Z. We have 5 nodes here in this graph. This is the source node S, this is the T node, this is the X node, this is Z node, and this is Y node. The initialize source node, the first step, initialize source node means we have to take distance of S is as 0. The distance of S we have to initialize as 0, and we are having so many edges when weighted edges among whole graph, and we have to initialize other vertices also in the same step. Means initialize when we are initializing the single source, we have to initialize distance of S as 0, and all other vertices we have to initialize as infinity. Then we have initializes infinity. This means from for reaching vertices T, infinity value, for reaching vertices X, again infinity value, for reaching vertices Z, again infinity value, for reaching Y, we have another infinity value. So, this is the first step, we have covered this. Means all vertices are we have taken infinity, and source we have taken 0. These are the initial values. After that, what the next thing? We have to complete the two sets. We have to initialize two sets S or Q, S and Q. Initially S is as infinity or phi. S is phi. We have neither no one node has been covered till now, and Q the to be covered node. To be covered node, we have to cover all the nodes, means all the 5 nodes we have written in S, T, X, Y, Z. Next thing, when we have initialized 0 to S, means we have started the minimum distance to be taken for covering the all the nodes. Means we have initialized S as 0, means we have covered source node from source node itself with the distance value 0. Means S has been cut down from Q set and will be included in covered node S set. Means all the vertices which are in Q, these all vertices, they will be come under set S one by one by making the two processes, initializing and relaxation. Then after covering S, we are here and we have to cover the next 4 vertices T, X, Y and Z. For the all other vertices, we have to check the minimum value. Means from source node S, for which at distance 0 we are at source node S, then we can go to their adjacent node. So, their adjacent node will be T and Y. There are only 2 adjacent nodes are there. Means adjacent node of S. So, S belongs to adjacent of which another node? T and Y. So, S belongs to adjacent means T or Y, that is the adjacent of S. Means if we go from S to T, then we have to calculate the distance of V, means next to be covered node. The next to be covered node is T. Means we have to take the dt, means distance to be taken for covering the to the path from so starting node to T. Means we have to calculate dt for this and dy for this. Then we are here for covering dt and dy similarly simultaneously. The formula is again same. When we are checking dv greater than equal to du plus the weight of edge from reaching there to here, means from where we are at dt, from u node means s node, means if we have taken t as v, then what is the node u is ds, distance of s is 0, this is 0, and w of weight of s to t, the s to t, the w of s to t means u comma v. So dt will be greater than equal to ds plus w of s comma t, means we are checking at this thing, this step means relaxation. So dt was initially infinity, so we have put it infinity here. ds, distance to be covered as, is 0, and w of s comma t, s to t we have value of age is 10. 0 plus 10 we have taken 10, and dt similarly, means infinity is greater than equal to 0 plus t, it means this is true, and when this is true, then we initialize dv is equal to the whole value which is less than infinity, means if this thing is less than infinity or the statement is true, we have to initialize this whole value to dt, means the minimum value. Lastly, we had here infinity, and now we have the value 10, that means 10 is smaller than infinity, means we have to reach from s source node to t node with the value of 10. And similarly for dy, we have taken from ds plus w s comma y means infinity, dy was infinity initially, ds distance for reaching s is was 0, and this is for wsy is 5, then dy greater than equal to 5, means we are having two values. For reaching t we are having 10 now, for reaching y we are having 5 now. Then we can replace this graph from this graph, means source node 0 to 10 we are here, 0 to 5 we are here, and we have covered these two edges, and or we can say by using these two edges we are at starting node, we are from starting node we are at t node and y node, means from single source we have covered two nodes with the value 5 and 10. Then next node, and if we have taken the value minimum value from among 10 and 5 for reaching for further next nodes, then we have selected this thing, from 5 we are reached here, then we have to explore from y to t, x and z like this, means in S set there was only s, lastly there was only s when we have taken it as from distance 0, and we have choose y node by taking distance 5, then y is also covered in set y, set s, means s and y are is now in set x, means s has been covered, y has been covered, means t, x and z all are also to be covered, means then we see the distance from y node to all other nodes, means we have to see the adjacent nodes of y, means adjacent node of y belongs to adjacent of t, x and z. Then we have adjacent of y are t, x, and z. Means here we have to calculate three things: dt, dx and dz. Similarly, dx greater than equal to already we have taken distance 5 plus and 3 for reaching t, 3 means for dt we found the value 8. Initially from the last step that was 10, and now we are having 8. Means the shortest path we have discovered from source node, which is 8, taken cost as 8, and initially it was directly from last step it was 10. It means we have to take this 8 value, means we have to initialize dt as 8. Next any other possible shortest distance is not possible. Next for dx we have another 5 plus 4, dx is equal to 14. For x we have to initialize 14. For dz from 5 plus 2 we have 7. For that we have no previous value, means that was infinity and infinity. So then infinity is greater than 5 plus 4, 9, 5 plus 9 is equal to 14, means infinity was greater than equal to 14. It means dx will be taken as 14 only, and 5 plus 2 is equal to 7, means infinity is greater than equal to greater than 7, means dz will be taken as 7. So now for this, till this step we are having, for reaching y node we are having value 5, for reaching t node via y node value 8, for reaching x node we are having value 14, for reaching z node we are having value 7. Next after that from y to we have covered t, and we can come to minimum value, means earlier we were having 10 and 5, then we have choose 5, then from 5 distance d5 means y node we have explored all the further nodes. Now we have from y to 8, 14 and 7, means 7 is smaller. Then we comes to z. So z node, from z node we have to explore another nodes, means x and t if possible, means x and y y, and we have choose as a smaller node z, means z is also covered in S set, means we have covered S, y and z, means further 2 nodes are also be covered. The z has adjacent value of S and x. So S has been already covered, and we have another value is x. We have to compute dx. For computing dx, so from dz where we have 7 value, from 7 plus the edge which is going to from z to x is 6, which will be for 13, and earlier that the value we were having is 14, means 14 is greater than 13, and if the value condition is true, then we have to assign the minimum value, means earlier it was 14, now it is 13. So we have to assign the value 13 and we have to assign value 13, and after that we have taken s y z and t, and value t and t, if we have taken t, then we can go from t to x also, means 8 plus 1 from x t to x means 8 plus 1, we are having value 9, means for reaching x node we are having two values, it means we have to select the minimum value. Minimum value means from value 13 and 9 we have to assign the minimum value, means earlier it was having 14, then it was for 13 for using this node, and if we do not use this age, we can use this age and this age, by which we are having only 9 value, means source node already covered. Then with weight value 5 we reached y, with weight value 2 we reached with 7 z node, with 3 value we covered 8 value with t node, and with 1 value of age we covered the node x with total weight is 9. It means the whole graph has been covered with the minimum possible values of the shortest path. This is the final answer which we have seen from this algorithm, means we have started from source node with the value 0 and we have taken the value of age 5 and 10. There were the two possible values were there. We have chosen 5, we reached node y with value 5. After that we have taken value 2 and reached z node with final value 7. From y we have taken 3 value as age value and we reached t node with total value 8, and with taking value 1 of age node, then we comes to x node 9. This is the shortest path for reaching each possible vertices from the single source shortest path. So, this is the discussed algorithm which gives the shortest path for each vertices present in the graph from a single source with minimum value. Thank you.